Assalamualaikum and good day to everyone. My name is Dr. Rafida Rosman. I am from School of Electrical Engineering from UiTM Shah Alam. I'm going to present my research entitled Non-Destructive Measurement on Kwini Mango Fruit using Capacitive Sensing Technique for Non-Destructive Fruit Ripeness Determination. The presentation today, I'm going to briefly mention on the background on fruit sensing system, literature study, the problem statement and the proposed solutions, my methodology and experiment setup, and then we will share our results and discussion. And finally, we will conclude and give some recommendations for future work. Production. Kwini mango fruit is a tropical fruit originated from West Malaysia and is widely grown in Borneo, Sumatra, Java, and southern Vietnam. The medium-sized round fruit grows on trees that can reach heights of 10 to 30 meters. As the fruit matures, it changes from green to yellowish green with dark brown spots, and the flesh becomes orange-yellow in color, sour, sweet, and juicy in flavor. Quinine mangoes require careful handling to retain their freshness and quality due to their perishability. However, transportation and storage can also lead to premature spoilage, which is a significant concern for the fruit's freshness and quality. Fruits including quinine mangoes are essential parts of a healthy diet as they provide various nutrients such as vitamins, magnesium, beta-carotene, and potassium. Quality and safety are critical in the food market, and the expanding industrialization and agriculture make technology necessary. Traditional manual sorting methods are inefficient and unreliable for assessing quality factors such as appearance, flavor, and texture. Therefore, a non-destructive and effective measurement tools are crucial for the development of the fruit industry. Fruit ripeness and challenges. One important quality aspect of fruit is the ripeness, which is usually determined by changes in the skin color, softening, starch conversion to sugars, acidity reduction, and also the production of flavors and aromas. Quinine mango's greenish appearance can make it difficult for consumers to determine their ripeness, leading to delays in consumption. Research and experimentations are needed to understand the characteristics and behavior of quinine mangoes during the ripening process. For this research, what we did is we used a capacitive sensing technique to determine the value of the capacitor or the value of the permittivity of the sample. For example, when we use a parallel plate capacitor made of copper, so we can measure the capacitance actually, and then we can also predict the epsilon r or the permittivity of the sample because C is also in the formula of epsilon r, epsilon naught times A over D. So ER here will provide the dielectric permittivity of the sample. E naught is the dielectric constant of the air. A is the area of the parallel plate and the D is the distance between the two parallel plates. The flow chart that we use, in which first we have to obtain the sample from local sellers, and then after that we have to maintain the fruit quality by take care of the fruits, okay, and we put it under the room temperature for a few days. So before the experiments are being done, we have to measure the diameter and the weight, okay, and the experiments is done between 4 to 5 days for natural ripening, for the natural ripening occur. And the experiment is focused on the TSS or the Brix level, in which it is a measurement of sweetness level, and then we also conduct measurement on the capacitance at various frequencies, and from that capacitance measurement we can also predict the permittivity readings. This is the capacitance measurement looks like when we place the fruit sample in between the parallel plate. It will provide, basically it will provide the capacitance value by implement the voltage divider rule lah. Okay, and then the formula is given as per shown in the diagram. The objective here is we want to assess the ripeness of the Kwini mangoes, and we use 10V peak to peak at 5 frequencies: 250K, 500K, 750K, 1 meg and 2 megahertz. Definitely the measurement, the frequencies is actually, we also referred to a few researchers, okay, and we select that these 5 frequencies is what we want to analyze lah. We measure the output voltage using a multimeter, okay, and then the copper plate thickness is 2 millimeter. This part here represents the measurement on the destructive. Okay, earlier we measured the capacitance, right? So the capacitance is basically measurement on the non-destructive. So now we want to relate the destructive and non-destructive. So what we did here in destructive is that we measured the bits content, okay, using the refractometer or the bits meter. This will give you the sweetness level. And then secondly, we will use pH meter to measure the acidity of the fruit juice. Okay. As part of the destructive measurement also, we measure the moisture content. Okay, moisture content is we put the samples into the drying oven at 75 degrees Celsius for 24 hours. Okay, and that it is cooled to room temperature before weighing. The formula for moisture content is that the initial mass initial mass minus the mass after the drying oven, and then divided by the initial mass multiplied by 100%. So we get the moisture content percentage. So as a result, okay, we can see that the moisture content ranges from 60 to 79%. And over the days, the Kwini mango will go through the overripe stage. So when there is an overripe stage, the bricks will be decreased. Okay, and as the mangoes become overripe, the moisture content tends to increase, indicate a softer and more watery texture. However, the bricks level is decreasing over the days because it has been overripe. So part of the analysis also, we can measure or we can relate the bricks with the moisture content. We can see that when the moisture content decrease, the bricks level is increased. Okay, and then the days versus pH. Okay, and also the bricks versus pH level. So all the analysis here is obtained from the experiment that we provide. We also look at the different frequency, okay, the effect of the different frequency used. Just now we mentioned that we start from 250K to 500K and then 750K and then 1 meg and 2 meg. So we try to get what are the effects of the different frequencies to the capacitance level, and we try to get the most or the best equation that we can have by referring to the regression analysis. Okay, for example, when we look at data between day versus capacitance, we can say that maybe 500 kilohertz is the best because it provides the highest regression. We also look at the moisture content versus capacitance and pH versus capacitance at those 5 different frequencies. And again, we analyze, we look at what is the best equation, and it happened okay, again at maybe 500 kilohertz. In order for this project to be able to be used by seller maybe, so we create a calculator using apps. Okay, we use MATLAB to estimate the value of the bricks level, okay, by only inserting the value of the capacitance or the value of the permittivity, meaning that we can predict the bricks level or the sweetness level by only measuring its capacitance or measuring its dielectric permittivity or the ER. As a conclusion, okay, this research demonstrated the successful application of the capacitive sensing technique as a low-cost, non-destructive method for determining the ripeness of Kwini mango fruit. By using the capacitance formula, the technique was able to predict fruit ripeness with high accuracy. So among the frequency tested, we found out that 500 kHz was found to be the most effective operating frequencies for Kwini mango fruits due to its high R-squared value and sensitivity in linear regression. So the correlation between bricks and capacitance also produced promising results in this project. The non-destructive nature of this technique provides a valuable tool for the agriculture sector to meet local market demand. As a future recommendation, we would like to increase the number of samples tested so that we believe it will be more precise and accurate data. And overall, this study demonstrated the potential for capacitive sensing as a valuable tool for non-destructive fruit ripeness determination. That's all from me. I would like to thank for this opportunity to present to you all uh, for this conference. And if there is any questions and maybe possible collaboration, you may contact me at the display email address.